Galileo performed the two experiments. In the first experiment, he has taken the inclined surface like this, and a ball is rolled from some height, and then he has taken one more surface. Now, after rolling the ball, what he observed, the speed of the body increases when it comes down, and when it reaches to the horizontal surface, it moves some distance and then it comes to the rest. Now he has performed lot of changes in this experiment. He has taken this horizontal surface of different smoothness, and what he observed, that body is moving more distance in the horizontal plane if it has greater smoothness. That means its friction is less, it is offering the less friction. So he concluded that if this horizontal surface have zero friction, then it will continue to move and it will not stop. This was the first experiment performed by the Galileo. Second experiment he has performed, he has taken both the slanting surfaces and one horizontal smooth surface, and he rolled the ball, and after some time ball will reach at this position. It travels uniformly. What he observed, it travels uniformly through this, along this smooth surface, smooth horizontal surface, and it tried to reach the same height here also on this inclined plane B. If I consider this as inclined plane A, and if I consider this inclined plane as B, so whatever the height it has reached, it is same. It tried to attain the same height. If he has taken, if it has rolled the ball from this position, it will reach to this position. Now, what he concluded, he has one more he has make one more change here. He has increased this length and performed this activity many times, and every time this ball reached to the same height at which it was what we can say released. Now he concluded, if I go on changing the slope of this surface, still it will try to reach the same height, but in that case it will travel more distance because it has to reach the same height through which. So suppose it has thrown from this height, it will try to reach this here at this height, but in this case it will travel longer distance. If he has taken this slanted surface, so to reach the same height it will reach to this position. In ideal case, if this black surface or this horizontal surface is perfectly horizontal, or this inclined surface is perfectly horizontal, so to reach to this original height the body will continue to move. So from this he has concluded that body will continue to move over the smooth surface if its friction is zero. From this experiment, the Galileo concluded that no external force is required to keep the body moving. After Galileo's experiment, what he concluded is known as the laws of inertia. According to Galileo, if the net external force acting on a body is zero, then a body at rest continues to be at the rest, and the body in the uniform motion continues to be moved with the uniform velocity, and these are known as the Galileo's law of inertia. The inertia means actually the resistance to the change. Now, the word external force, no external force, no external force. Here word external is very important. When body is moving, if there is some external force like friction or air resistance, body will surely come to the rest. But when he increased the smoothness of the surface and neglected the air resistance, what he concluded that body should keep moving, but if there is some opposing force, then certainly it will going to come to the rest. And that whatever he has concluded, he has formed a statement, and that is known as law of inertia. He has also described the meaning of inertia, that is resistance to the change. It can be resistance to the change of state of rest. A body is in state of rest, it will be continue to be in the state of rest. If it is body is moving with uniform motion, it will be continued to be in the uniform motion if no external force is applied. And there is one more concept related with inertia. In fact, inertia means actually resistance to the change. If body is moving in this direction, it will be moving in the same direction unless and until it is applied by the external force, due to which its direction will change. So this is all about the Galileo's experiment, concept of inertia and law of inertia. One more thing we should know, that inertia of the body is related with its mass. For example, there is a object of 5 kg and there is an object of 50 kg. Both are at the state of rest, but to bring them motion, 50 kg we have to apply the more force, and for 5 kg we have to apply the less force. So inertia again depends on the mass of the body. Imagine the body, these two bodies once again, but they are now moving. Again, to stop the motion of 50 kg body will be difficult. We have to apply the more force, more opposing force. Thus inertia depends on the mass of the body.